Welcome to the Sigma Magic software series. In this module, we will cover a brief overview of how to create an X-bar control chart using the Sigma Magic software. An X-bar control chart is used to determine if a process is in control when we have a continuous metric, and there are between 2 and 10 data points in each subgroup. For example, let's say we are interested in determining if the outside diameter of PVC pipes are in control. We monitor 4 diameter readings for each pipe. This is a continuous metric, and the subgroup size is 4, so we use the X-bar chart for this analysis. The data for this exercise is given in the variable dia group and diameter in the data file, 6 Sigma training data. To perform this analysis, the first step is to add the X-bar control chart template to your workbook, by clicking on Stats, and then selecting Control Charts. Once you add the template, click on Update Inputs, to open the input dialog box, and specify the options for this analysis. In the Data section, specify the data type as continuous. You can either define the subgroup size information in the worksheet, or as a constant in the dialog box. Let's choose the subgroup size as defined in the worksheet, and that there are no stages for this analysis. In the Control Charts section, select the X-bar chart, specify that the control limits are to be estimated from data, and select the option of performing all tests. Click on OK, to save the options, and enter the data on the worksheet. In the worksheet, you can either copy and paste the data into the Inputs area, or paste the data from a data file. Let's use the Paste option for this exercise. During the IMR control chart analysis, we had already set the data file to 6 Sigma training data in the Options menu. Click on Paste, and select the variable diameter group column for the subgroup ID and diameter column for the data columns. This will paste the data into the Inputs area, and then compute the analysis results. If you had manually entered the data in the worksheet, you will have to click on Compute Outputs, to generate analysis results. The summary of analysis results is shown in the Notes section, and the X-bar and range control charts are shown in the Graphs section. From the Notes section, we can see that there are 40 data points, and that one data point is not in Indiana control. The average value and control limits for both the X-bar chart and R charts are listed here. The data points that have failed the control chart tests are shown in the out of control points. In this case, test number 1 has failed. We can click on the Help file to identify this test. Test 1 refers to any data point falling outside the control limits. The specific points that are not in control are shown by the red dot on the control charts. In summary, this process is not in control. We need to investigate the reason why the process is not in control at these specific points, and take corrective action to bring the process back to control. Let's take a quick look at a problem that has stage information, such as data points before and after an improvement. We can specify that our data has stage information in the options for this analysis. Click on Update Inputs, specify that the data has stages, and when you click on OK, a new column to enter stage information is shown on the worksheet. Click on Paste, and select the stage column. From this analysis, we can see that the original process before the improvement, and the process after the improvement, are both in control, and that the variation has also been reduced. We hope this module was useful to get a high-level overview of how to create the X-bar chart using the Sigma Magic software. Check out the other modules in this series, to learn more about the different capabilities of the Sigma Magic software. Thank you for watching.